Good morning, student. So today this is our second lecture on the topic electrostatics. In the last period we had seen what are the basic properties of electric charges, and today we will discuss one of the most important law in physics, that is Coulomb's law. Now as far as Coulomb's law is concerned, you had an idea that if we are having the 2-point charges, say charge Q1 and that of Q2, there are 2-point charges and they are at rest with respect to each other, and they are separated by a distance r apart. Then from the properties of electric charge, you know very well that the point charges which are at rest and they are kept in free space or vacuum, then the electric charges, they must exert either a force of attraction or a force of repulsion on each other, depending upon whether the two charges they are like charges. Like means positive positive or negative negative, or depending upon whether they are what, unlike charges. But one thing is clear, one thing is sure, that whenever point charges they are kept at a finite distance apart in any medium, they must exert some force on each other, maybe force of attraction or maybe force of repulsion. And if I say that F represent the force of attraction or force of repulsion between what? The 2-point charges which are at rest. The force of attraction or force of repulsion between the 2-point charges at rest. Then Coulomb says that this force of attraction or repulsion between the 2-point charges which are kept at a finite distance r apart, it is directly proportional to product of magnitude of the charges. Product of magnitude of the charges. Whereas that force of attraction or repulsion is inversely proportional to square of distance between the charges. Square of distance between the two charges. So, as far as Coulomb's law is concerned, Coulomb's law states that the force of attraction or repulsion between the 2-point charges which are at rest. See, here I can write the force of attraction or the force of what? Attraction or repulsion. Force of attraction or repulsion between what? Between the force of attraction or repulsion between the 2-point charges, between the 2-point charges which are at rest, the force of attraction or repulsion between the 2-point charges at rest, you can also say the 2-point charges at rest, is directly proportional to, see here, directly proportional to what? Directly proportional to the product of what? Product of magnitude of the charges, product of magnitude of the charges, and is inversely proportional to, see here, it is inversely proportional to what? Inversely proportional to the square of, inversely proportional to the square of distance between the charges, square of distance between the charges, square of distance between the charges. So listen carefully. Between the 2 point charges which are at rest with respect to each other and which are kept in a free space or a vacuum, Coulomb's made a statement that the force of attraction or repulsion between the 2 point charges which are at rest is directly proportional to product of the magnitude of charges, product of magnitude of the charges, and is inversely proportional to square of distance between the charges, square of distance between the charges. It means if we will take Q1 and Q2 as the 2 point charges, let Q1 and Q2 are the 2 point charges and they are at rest with respect to each other and they are kept at a distance r apart, means distance of separation between the two charges is what? R. And if these two charges they are kept in what? Vacuum, then according to Coulomb's law, the force of attraction or repulsion between the 2 point charges which are at rest is directly proportional to product of their magnitude. Means F is proportional to Q1 into Q2, product multiplication of magnitude of given two charges, and that force of attraction or repulsion is inversely proportional to square of distance between the two charges, means F is proportional to 1 upon r square, inversely, that's why 1 upon r square. And you know that these two equations they implies that the force of attraction or repulsion between the 2 point charges at rest is proportional to Q1 Q2 divided by what? R square. Q1 Q2 divided by what? R square. Or the force of attraction or repulsion between the 2 point charges which are at rest separated by a finite distance r apart in a free space or in a vacuum is equal to k into Q1 Q2 divided by what? R square. Here k represents constant of proportionality and the value of k, it depends on value of k, it is a constant of proportionality and its value will depend on the unit in which we will measure the two charges, the unit in which we will measure the distance of separation between the two charges and the force of attraction or repulsion between the two charges. Remember, if we measure the two charges in SI unit, that is Coulomb, if we measure the distance of separation between two charges in SI unit of length, that is meter, and if force of attraction or repulsion between the two charges were measured in Newton, then the value of k, it is found to be equal to 1 upon 4 pi epsilon 0, where epsilon 0 will represent absolute permittivity of free space or a vacuum. Epsilon 0 is called absolute permittivity of free space or absolute permittivity of vacuum, and value of epsilon 0, it is equal to 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square is found. So, the expression for the force of attraction or repulsion between the 2 point charges which are at rest with respect to each other and which are kept in vacuum at a distance r apart is given by F in vacuum is equal to. Now, in place of K, we can write 1 upon 4 pi epsilon 0 Q1 Q2 divided by what? R square. Q1 Q2 divided by R square. Remember, this force may be a force of attraction or it may be a force of repulsion depending upon the polarity of two charges. Now here, what are the possible cases that we will see? Now, suppose both the charges Q1 and Q2, charge Q1 is positive, Q2 is what? Negative. Means, if I show the charge Q1, here positive charges are deposited and charge Q2 is negative, so negative charges are deposited and they are separated by a distance r. So, these two charges, they are what? The two charges, they are what? Unlike charges, because one is positive, other is what? Negative. And from the properties, basic properties of electric charges, you know that whenever unlike charges they are brought near to each other, then always there exists a force of attraction, and according to Coulomb's law, that force of attraction or repulsion, it will always act along the line joining the two charges. Here, the two charges, they are unlike charges, so they will attract each other. And that force of attraction, it will act along the line joining the two charges. Or, this force between the 2 point charges, suppose charge Q1 and that of Q2, both are positive charge or both are what? Negative charge. So, when the 2 point charges, they are like charges, maybe positive positive, maybe negative negative, they are at rest, separated by a finite distance r, kept in a vacuum. Then, even in this case, the force between the two charges will act along the line joining the two charges. This is a line joining the given point charges. So, because here we are having like charges, so the force between them is what? Force of repulsion, and that force of repulsion, it will act like this. Means it will try to repel both the charges away from each other. So, remember, according to Coulomb's law, whenever 2 point charges which are at rest and kept at finite distance apart in a vacuum or in what? A free space, then the force of attraction or force of repulsion between the 2 point charges which are at rest is directly proportional to product of magnitude of two charges and is inversely proportional to what? Square of distance between them. This force will act along the line joining the given two charges, and depending upon whether the charges are like charges or whether the charges are what? Unlike charges. That force may be a force of attraction or that force may be a force of repulsion. So, if given 2 point charges, one is positive, other is negative, means they are unlike charges. Between the unlike charges, there exists a force of attraction, and that force of attraction will act along the line joining the given two charges, and between the like charges, means positive positive or negative negative, how is the force? Force is force of repulsion. But this force will also act along the line joining given two charges. So for unlike charges, force is force of attraction, and for like charges, force is force of repulsion. For unlike charges, force is what? Force of repulsion. Now we will discuss one of the important concept, that is relative permittivity or dielectric constant of a medium. Sometimes it is also known as inductive capacity. Now you know that according to Coulomb's law, when the 2 point charges Q1 and Q2, which are at rest and they are separated by a distance r apart, the 2 point charges which are at rest, suppose they are kept in free space or in vacuum, then according to Coulomb's law, the force of attraction or repulsion between the 2 point charges which are at rest in vacuum separated by a distance r apart, it is equal to 1 upon 4 pi epsilon 0 q1 q2 divided by what? R square. Why it is so? Because that constant of proportionality k, its value is found to be 1 upon 4 pi epsilon 0, because we had measured the charges in Coulomb, distance in meter, and force is measured in Newton, so k is found to have this value. Here epsilon 0, it is known as permittivity of free space or vacuum, and its value is epsilon 0 equal to 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Coulomb square per Newton meter square. Now, we want to study what happens to the force of attraction or repulsion between the 2 point charges which are at rest if these charges are kept in the dielectric materials like water or mica, or it may be a sheet of paper which is paraffin. So let us consider that the 2 charges Q1 and Q2, which are point charges, they are at rest with respect to each other and they are r distance apart. And if they are kept in a dielectric material whose permittivity is epsilon, 2 point charges Q1 and Q2, which are stationary, which are at rest with respect to each other, they are at a distance r apart and they are kept in a dielectric media having permittivity epsilon, then the force of attraction or repulsion between the 2 point charges which are kept in given media, it is 1 upon 4 pi. Now instead of epsilon 0, we will write epsilon q1 q2 divided by r square. Here what epsilon is known as? Epsilon is absolute. Epsilon is what? Absolute permittivity. Absolute permittivity of the medium in which the charges were kept. Absolute permittivity of medium. Epsilon 0 is what? Permittivity of free space. Now, let us take the ratio of F vacuum, that is ratio of force between the point charges in vacuum to that of force between the point charges in media, in a dielectric medium. Then it is found to be equal to 1 upon 4 pi epsilon 0 q1 q2 divided by r square whole divided by 1 upon 4 pi epsilon q1 q2 divided by r square. 4 pi q1 q2 upon r square, q1 q2 upon r square, they get cancelled and it is left with epsilon divided by epsilon 0. So this ratio of epsilon divided by epsilon 0 or F vacuum upon F media, it is known as, or it is defined as, relative permittivity of a medium, or it is also known as dielectric constant K of a medium. What we want to study? Relative permittivity means what, or dielectric constant K of the media means what. So here we will get some mathematical expression for dielectric constant or relative permittivity, that K or epsilon r, dielectric constant or relative permittivity. It is a ratio. What you can say? Relative permittivity is a ratio of absolute permittivity of the medium to the permittivity of free space. So how you can define the relative permittivity? Relative permittivity, it is defined as the ratio of absolute permittivity of medium to the permittivity of free space, or relative permittivity can also be defined as the ratio of force between the 2 point charges. Ratio of force between the 2 point charges which are at rest at certain distance apart in a free space or vacuum, to that of force between the same two charges which are at same distance apart but kept in a given medium. See what I am saying? Dielectric constant of the medium or relative permittivity of the medium, it is defined as the ratio of absolute permittivity of the medium to that of permittivity of free space, simple, or dielectric constant or relative permittivity, it is a ratio of force between the 2 point charges which are at rest separated at finite distance apart, separated by a finite distance apart in free space or in vacuum, to that of force between the same two charges, same 2 point charges, separated by same distance apart but kept in a medium, is called dielectric constant K of the medium, is called dielectric constant K of the medium. Now you can express the force of attraction or force of repulsion between the two medium in terms of relative permittivity or in terms of a dielectric constant. So let us see here that by using this expression here, epsilon upon epsilon 0 is epsilon r. So what this implies? That epsilon equal to either epsilon 0 or epsilon r into epsilon 0, or K is equal to epsilon by epsilon 0, means epsilon is equal to epsilon 0 into K. So one can express the force of attraction or repulsion between the 2 point charges which are kept in a media having permittivity, absolute permittivity epsilon or relative permittivity epsilon 0 or dielectric constant K. See what I am saying? That the 2 point charges, they are kept in such a media, dielectric media, whose dielectric constant is K, or whose absolute permittivity is epsilon, or whose relative permittivity is what? Epsilon r. Then the force of attraction or repulsion between them, it can be expressed as F is equal to 1 upon 4 pi epsilon q1 q2 divided by what? R square. This is equal to, now you can replace epsilon by what? Epsilon r into epsilon 0. So this is 1 upon 4 pi epsilon r into epsilon 0 q1 q2 divided by what? R square. Or you can replace epsilon by what? Epsilon 0 into k. This is equal to 1 upon 4 pi epsilon 0 into k q1 q2 divided by what? R square. So you can express the force of attraction or force of repulsion between the 2 point charges which are at rest, which are kept in a dielectric medium of dielectric constant K or absolute permittivity epsilon by this expression. Remember that as far as dielectric constant K or relative permittivity epsilon r of the medium like water, for water is a dielectric medium. The value of dielectric constant or relative permittivity of water is nearly 80, and as this epsilon r or k is equal to F vacuum upon F medium. So here F vacuum upon F, what is that media? Water. As the relative permittivity or dielectric constant of the water is 80, so 80 equal to F vacuum upon F water. Now we want to study, see here, from this F water is equal to F vacuum upon 80. And what conclusion you can draw from this mathematical equation? The force of attraction or repulsion between the 2 point charges when they are kept in water at certain distance apart, it reduces by, or it reduces to 1 by 80th of the force between the same 2 point charges at same distance apart, but when they are kept in what? Vacuum. See here what I want to say. F water is equal to 1 by 80 times F vacuum. What F water? It is the force between 2 point charges. Force between 2 point charges. They are placed at some distance apart. They are placed at what? Some distance apart in water. It is found to be 1 by, or it reduces to what? 1 by 18th times. Force between 2 point charges which are kept in water at certain distance apart is 1 by 80 times the force between same 2 point charges which are separated by same distance apart, but when they are kept in what? Vacuum. In other words, what you can say? That is a dielectric media or material media. Material medium or dielectric medium, they helps to reduce the force between the point charges. Material medium or dielectric medium, it helps to reduce the force between, it helps to reduce the force between what? Force between the 2 point charges by a factor of epsilon r, that is relative permittivity, means F medium is equal to F medium is equal to F vacuum divided by K, or F vacuum divided by what? Epsilon r. So material medium reduces the force between 2 point charges by what factor? By a factor of what? Dielectric constant or relative permittivity. So in short, you remember that whenever charges, same charges are separated by same distance apart, instead of vacuum, if they were kept in a material medium, then the force between them reduces by a factor equal to its dielectric constant of media, or it is equal to what? Relative permittivity of medium. Now we will see how to define the SI unit of charge. You know very well what is SI unit of charge? It is a coulomb. Now according to Coulomb's law, when the 2 point charges which are at rest kept at finite distance are apart in a vacuum, then the force of attraction or repulsion between the 2 point charges at rest at a distance r apart in vacuum, it is given by formula 1 upon 4 pi epsilon 0 q1 q2 divided by what? R square. And here we can write F vacuum, means it is the force of attraction or repulsion between point charges which are kept in vacuum. We know very well that permittivity of free space epsilon 0, it is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. So if I put the value of 4 into pi means 3.142 into 8.85 into 10 to the power minus 12 into q1 q2 divided by r square. So this reciprocal of this entire number, it is found to be equal to 9 into 10 to the power 9 into q1 q2 divided by what? R square. Now if I just consider that I am having the 2 point charges both q1 and q2 and their magnitude is equal to 1 coulomb. Charge q1 is of value 1 coulomb, charge q2 is of value 1 coulomb, and let they are kept at a distance 1 meter apart in a vacuum. Then the force of attraction or repulsion between the 2 point charges each of value 1 coulomb separated by a distance 1 meter, it is found to be equal to 9 into 10 raised to 9 into 1 upon 1 square, means 9 into 10 to the power 9 Newton. Now everything is clear. Now here we can define what is 1 coulomb of charge. 1 coulomb charge is that amount of charge. 1 coulomb charge is that amount of charge which when placed in a vacuum, 1 coulomb charge is that amount of charge which when placed in vacuum at a distance of 1 meter away from the another charge of same magnitude will experiences a force of 9 into 10 to the power 9 Newton. What is 1 coulomb charge? 1 coulomb charge is that amount of charge which when placed in a vacuum at a distance of 1 meter away from the another charge of same magnitude will experiences a force of 9 into 10 to the power 9 Newton. Means if we are having 2 charges each of value 1 coulomb, and if they are separated by a distance of 1 meter in a free space or in a vacuum, VACWM vacuum, what is the force experienced by them? It is 9 into 10 to the power 9, which we had calculated already. So remember, if there comes a question, define SI unit of charge. SI unit of charge is coulomb. And 1 coulomb charge is that amount of charge. 1 coulomb charge is that amount of charge which when placed at a distance of 1 meter, from the another charge of same magnitude in a vacuum will experiences a force of 9 into 10 to the power 9 Newton. 1 coulomb is that amount of charge which when placed in a vacuum at a distance of 1 meter away from another charge of same magnitude will experiences a force of 9 into 10 to the power 9 Newton. See here, this force is very, very large. This force is what? Very, very large. Remember that Coulomb is SI unit of charge. You must know some other units of charge also, smaller units of charge also. If I say 1 millicoulomb, it means it is 10 to the power minus 3 coulomb. If I say 1 microcoulomb, micro means 10 to the power minus 6 coulomb. 1 nanocoulomb, it means it is 10 to the power minus 9 coulomb. 1 picocoulomb, it means it is 10 to the power minus 12 coulomb. 10 to the power minus 12 coulomb. Now here actually we want to write down Coulomb's law in vectorial form. So how to write down Coulomb's law in vectorial form? Just see here. So as far as Coulomb's law is concerned, we know the force between 2 point charges separated by a finite distance. It is given by 1 upon 4 pi epsilon 0 q1 q2 divided by r square. So let us consider here we are having two similar point charges q1 and q2, both are positively charged. We are having two similar point charges q1 and that of q2 shown by dark circles. So the two similar point charges, they are kept at point A and that of B. We can locate the position of charges in two-dimensional coordinate system. So vector r1 and vector r2 will represent the position vector. r1 will give you position of charge q1, r2 will give you what? Position of charge q2. So r1 bar and r2 bar, r1 bar and r2 bar, what are they? These are what? The position vector, and they are giving the position of what? Charge q1 charge and that of q2 charge. And here the line joining A and B is shown. As far as vector r12 is concerned, it is what? r12. It is a vector pointing from A to B. r21 vector pointing from what? B to A. See here, r12 and r21. r12 cap or r21 cap, it means they are representing unit vector. r12 is directed away from A. How is the direction of r12? Away from A. While r21, it is directed away from point B. See here, according to Coulomb's law, whenever point charges at rest separated by a finite distance r12 here, then both the charges will exert force on each other. When point charges at rest separated by a finite distance, both of them, they will exert a force on each other. If I say here F21, it is the force exerted on charge Q2 by charge Q1. F21, force exerted on charge Q2 by charge Q1. It is given by 1 upon 4 pi epsilon 0. Why epsilon 0? Because it is assumed that the two charges, they were kept in free space or in vacuum, into Q1 Q2 divided by F21, force exerted on second charge by first charge. Force exerted on Q2 by Q1. It is 1 upon 4 pi epsilon 0 Q1 Q2 divided by R21 whole square into R21 cap. Where what this R21 is? R21 is a unit vector along what? Along arrow AB and directed away from, how is the direction? Directed away from, see here, R21, it is a unit vector directed away from B, directed away from point B. Means this will give you the force exerted on charge Q2 by Q1, and this force will act along the line joining the given two charges. How is the direction of F21? It is along the line joining charge Q1 and Q2, and it is directed away. Similarly, this second charge will also exert a force on first charge, because when charge Q1 is exerting a force on charge Q2, force exerted on Q2 by Q1 is given by this expression. Similarly, F12 will represent, here I have shown F12, it is a force exerted on charge Q1 by charge Q2. Force exerted on charge Q1 by charge Q2, and it can be given as 1 upon 4 pi epsilon 0 Q1 Q2 divided by R12 whole square into R12 cap, where R12 cap, it is what? It is a unit vector. Unit vector along arrow BA, and it is directed away from, see here, F12, it is directed away from what? It is directed away from A. Directed away from A. Now, charge Q1 will exert a force on charge Q2 given by this expression. Charge Q2 will exert a force on charge Q1 given by this expression. Both the charges, they will exert force on each other, and these forces F12 and F21, which are the forces exerted by two charges on each other, they will act along the line joining the given two charges. And also, if you observe this figure carefully, then look at the unit vectors R12 pointing in a direction opposite to that of what? Direction of unit vector R21. So, the two unit vectors, that is R12 cap and R21, they are opposite in direction. No doubt they are equal in magnitude, equal to 1, but they are opposite in direction. So, R12 equal to minus of R21. R12 equal to what? Minus of R21. And as far as this distance R12 is concerned, magnitude of R12 equal to what? Equal to say R12. And magnitude of R21 is equal to what? R21, which is equal to, both are equal to R. So, as R12 equal to minus of R21, these two unit vectors are opposite in direction. So, naturally, see, the rest of the things are same. Magnitude of R21 or magnitude of R12, because magnitude of R12 equal to magnitude of R21 equal to say R. Therefore, now the relationship between the two forces F21 bar is equal to minus of F12 bar. So, what conclusion that we can draw? That whenever two similar charges, they are separated by some finite distance r apart, then both of them, they will exert a force on each other, and the force exerted by the charges on each other, they are equal in magnitude. The two forces are what? Equal in magnitude, and this negative sign indicates they are opposite in direction. They are opposite in direction. So this is the vectorial form of Coulomb's law. You can express the force of attraction or repulsion between the 2 point charges even in terms of what? The vectorial form. Now we will see what is that superposition theorem. So we can conclude that when the 2 point charges, they are kept in free space or vacuum, then the force exerted by each of them on one another, they are equal in magnitude but opposite in direction. In other words, F12 and F21, these two forces, they are equal in magnitude but opposite in direction, and they will act along the line joining the given two charges. It means F12 and F21, they will act like what? Action reaction pair of force. And as far as this electrostatic force is concerned, it is a central force. That is the important point to be noted, that the electrostatic force of attraction or repulsion is what? It is a central force. Now let us compare the two forces according to Coulomb's law. We know that whenever there are two charges which are separated by a finite distance r, then the force of attraction or repulsion between them, it is given by formula 1 upon 4 pi epsilon 0 q1 q2 divided by what? R squared. It means this electrostatic force of attraction or repulsion is directly proportional to product of magnitude of two charges, and this force of attraction or repulsion between the two charges, 2 point charges, it is inversely proportional to square of distance of separation between them. Now it was given by Coulomb. In the similar manner, Newton has given Newton's law of gravitation, and it states that between any two particles, say of masses m1 and m2 separated by a finite distance r, here there exists a force of attraction only, no repulsion. In case of electric charges, there might be a force of attraction if they are unlike charges. There might be a force of repulsion if they are like charges. So according to Newton, the gravitational force of attraction here, Coulombian force of attraction or the electrostatic force of attraction or repulsion. So the gravitational force of attraction between 2 point particle of masses m1 and m2 separated by a distance r, that gravitational force is proportional to product of the masses of two particles. This gravitational force is inversely proportional to square of distance of separation between them, or the gravitational force of attraction between the 2 point particle of masses m1 and m2 separated by a distance r, it is given by F suffix g equal to g m1 m2 upon r square. Here that g is a universal gravitational constant, and the value of that g is equal to 6.674 into 10 to the power minus 11 Newton meter square per kg square. Here the absolute permittivity of free space epsilon 0 is equal to 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Now we want to see what are the similarities between gravitational force and electrostatic force. What is the first point of similarity? Both will obey inverse square law, means electrostatic force or Coulombian force is inversely proportional to square of distance of separation between two charges. Similarly, the gravitational force of attraction between the two particles is inversely proportional to square of distance of separation between them. Means first similarity is that both will obey inverse square law. Both will obey what? Inverse square law. The second similarity means first similarity is both will obey inverse square law. Now what is the second similarity? That both the electrostatic force as well as gravitational force, they are central force. They are what? They are central force, means they will act along the line joining the two charges or along the line joining what? The two particles or the two masses. So because the electrostatic force of attraction or repulsion between two charges or the gravitational force of attraction between the two particles, they will act along the line joining the given two particle or line joining what? The given two charges. That's why you can say Coulombian force or electrostatic force and gravitational force both are the central force. So these are the points of similarities. There are two similarities, both will obey inverse square law, and both the forces, electrostatic force and gravitational force, they are what? Central force, because this force will act along the line joining either two charges or two particles. Now, what is the difference between them? See here. As far as electrostatic force is concerned, it exists between two charges. The electrostatic force, it may be a force of attraction or force of repulsion depending upon whether the charges are like charges or unlike charges. If charges are like charges, force of repulsion. Charges are unlike charges, there is a force of attraction. So electrostatic force may be a force of attraction or force of repulsion depending upon the polarity of charge, but gravitational force which exists between the two particles is always a force of attraction. So as far as difference between the two forces is concerned, here it is what? Similarities. Here these are the similarities, and here the difference. What is the first difference? That the electrostatic force, it may be a force of attraction or force of repulsion, but the gravitational force is always a force of attraction. Is always a force of attraction. Electrostatic force, it may be a force of attraction or force of what? Repulsion, but gravitational force is always a force of attraction. Now let us calculate, let us compare which force is more stronger than the other force. So for that purpose, if I just consider a proton, suppose we are having two protons, and we will find out what is the electrostatic force between the two protons. Suppose mass of proton, do you know what is mass, what is charge on proton? Magnitude of charge on proton is 1.6 into 10 to the power minus 19 Coulomb. Now, what is mass on proton? It is 1.67 into 10 to the power minus 27. 1.67 into 10 to the power what? Minus 27 kg. If the two protons E and they are separated by a distance 10 to the power minus 15 meter, and that too in what? Free space or vacuum. Here also we are having the two protons. Here what is the mass of proton? MP. Mass of proton is MP. Here charge on proton, and again two protons, they are separated by a distance r is equal to 10 to the power minus 15 meter. Remember here that if I calculate the gravitational force between the two protons separated by a distance 10 to the power minus 15 meter, then that gravitational force, what is the formula for gravitational force? F is equal to G m1 m2. First particle is a proton, Second particle is also proton, so mp into mp, where mp represent mass of proton, upon r square. Now what is the value of G? The universal gravitational constant, it is 6.674 into 10 to the power minus 11. Mass of proton 1.67 into 10 to the power minus 27 into 1.67 into 10 to the power what? Minus 27, and whole divided by r square, means it is 10 to the power minus 15 and its whole square. And it's what? Whole square. And if you just calculate this gravitational force between the two protons separated by a distance of 10 to the power minus 15 meter, then that value comes to be 1.86 into 10 to the power minus 34 Newton. Such a small gravitational force will exist between the two protons of mass 1.67 into 10 to the power minus 27. Now, let us calculate what is the electrostatic force between the two protons separated by same distance. We know the electrostatic force, that is Coulombian force. That electrostatic force between the two proton, it is equal to 1 upon 4 pi epsilon 0. Q1, Q2, here Q1 is proton, Q2 is proton upon what? R square. You know the value of 1 upon 4 pi epsilon 0, it is what? 9 into 10 to the power 9 into. What is charge on proton? 1.6 into 10 to the power minus 19, E into E square. So I can square it and divide it by 10 to the power minus 15, that is the distance of separation between the two protons. And if I calculate this force, it comes to be 2.3 into 10 to the power 2 Newton. So this is the force between electrostatic force of repulsion between the two protons separated by same distance r equal to 10 to the power minus 15 meter. So we are having the two situations. We had calculated what is the force between two proton, gravitational force between the two proton, and electrostatic force between two proton. And what we found? Fg, gravitational force between the two protons separated by a distance 10 to the power minus 15 meter is this much, and the electrostatic force is this much. And if I just compare these two forces, then Fe upon Fg, which one is greater? Electrostatic force is much more greater as compared to that of what? Gravitational force. So Fe upon Fg, 2.3 into 10 to the power 2 divided by Fg, it is 1.86 into 10 to the power what? Minus 34, and if you calculate it, it comes to be 1.23 into 10 to the power what? 36. It means electrostatic force is 10 to the power 36 times, approximately 10 to the power what? 36 times that of the gravitational force. Actually it is Fe is equal to 1.23 into 10 to the power 36 times that of Fg. So you can imagine that gravitational force is very weak, whereas electrostatic force or Coulombian force is 10 to the power 36 times stronger than that of what? A gravitational force. So what you can say? Gravitational force is 10 to the power 36 times weaker than the electrostatic force, or electrostatic force is 10 to the power 36 times stronger than that of what? The gravitational force. So remember, electrostatic force between proton or electrostatic force is what? Stronger as compared to that of gravitational force. And how they are related? Fe equal to 10 to the power 36 times that of force, gravitational force between the two bodies. Now again, one of the important concept, that is principle of superposition of charges. So whenever so many charges they are interacting, up till now in Coulomb's law, we had considered only 2 point charges and interaction between them. But instead of only 2 charges, when so many charges they are interacting, when many charges they interact with each other, and If we try to find out the resultant force on a particular charge, then it must be equal to vector sum of force exerted by what? The individual charges. So what is the principle of superposition of charge? It states that when so many charges interact with each other, then the force acting on a particular charge is equal to vector sum of force exerted by individual charges. What is that statement? The force acting on a particular charge, is equal to, what it is equal to? It is equal to vector sum of force exerted by individual charges on it. So remember, when more than two charges they are interacting, means so many charges they are interacting, and you want to find out what is the resultant force. You want to find out what? The resultant force on a particular charge. Then according to principle of superposition, the resultant force on a particular charge is equal to vector sum of force due to what? The individual charges on it. For example, look at this here. Here we are having a charge Q1 kept at point A1, Q2, Q3, Q4, Q5. These are the charges which are situated at point A1, A2, A3, A4, A5 respectively. Let us try to calculate what is the force acting on charge Q1. First by charge Q2, then by charge Q3, by charge Q4, by charge Q5. So force acting on charge Q1 due to charge Q2, it is what? F12. Vector F12 is equal to 1 upon 4 pi epsilon 0 Q1 Q2 divided by mod of R12 whole square into unit vector R12 cap. Similarly, force, and this force will act along this direction. Here R12 is a unit vector directed towards Q1 from Q2. R12 is a unit vector directed to Q1 from Q2. Similarly, the force acting on first charge, that is force acting on charge Q1 due to charge Q3, it is equal to 1 upon 4 pi epsilon 0 Q1 Q3 divided by R13 bar and its square into unit vector R13 cap in this manner, and this force F13 is acting along this arrow. So you can calculate the force acting on charge Q1 first due to Q2, then due to Q3, Q4, Q5. Then according to principle of superposition, the net force acting on charge Q1, if I say F1 will represent the resultant force on charge Q1 due to charge Q2, Q3, Q4 and Q5. What F1 is? It is the resultant force acting on charge Q1 due to charge Q2, due to charge Q3, due to charge Q4, due to charge Q5. Then according to principle of superposition, this vector F1, it must be equal to F12 plus vector F13 plus vector F14 plus vector F15 and so on. You can continue up to nth charge. Or this vector F1, that is the resultant force on charge Q1, is equal to, now what I can take common? 1 upon 4 pi epsilon 0. It can be taken common. So what is left in bracket? It is a Q1 Q2 divided by mod of R12 square into R12 cap plus Q1 Q3 divided by mod of R13 square into unit vector R13 cap. So in this way, mod of Q1 Qn divided by R1n square into R1n cap. R1n cap. So here is the resultant force acting on charge Q1 due to charges Q2, Q3, Q4, Q5 and so on. Remember here R12, R13, R14, R1n, these are the unit vectors directed to Q1 from Q2, Q3, Q4 and Q5. While R12, R13, R14, R1n, these are the distances of charge. R12, it is the distance of charge Q1 from Q2. Distance of charge Q1 from Q3. So R12 distance between Q1 and Q2, R13 distance from Q1 to Q3, R14 distance from Q1 to Q4. So remember, what is the principle of superposition? That when so many charges they are interacting and you are interested in finding what is the resultant force on one of the particular charge, then it is equal to what? Vector sum of force exerted by the individual charges. Let us have another situation where we are taking a test positive charge Q0. We may have a test positive charge Q0, and on that test positive charge, suppose we are having n different charges Q1, Q2, Q3, Q4 up to Qn. They are kept at distance R1, R01, R02, R03, R04, R0n from the test charge. Then if I say that charge Q1 will exert a force F1 on test positive charge, charge Q2 will exert a force F2, means F1, F2, F3, F4 up to Fn. These are the force exerted by Q1, Q2, Q3, Q4, Qn on a test positive charge Q0, then the net force on test positive charge, net force on test positive charge, it can be expressed in terms of a summation sign, that is F1 plus F2 plus F3 up to what? F suffix capital N, or it can be equal to summation of Fi, Fn, n takes value from 1 to capital N, or that force acting on test positive charge is equal to 1 upon 4 pi epsilon 0 into summation of Q0 Qn upon R0n whole square into R0n cap. Here n takes value from 1 to what? Capital N. N takes value from 1 to capital N, where this R0n cap, what is this R0n cap? It is a unit vector. It is a unit vector directed from nth charge to the test positive charge, to the test positive charge. So this is all about principle of superposition. Now in the next period we will see the remaining bits.